All right, waiting for some attendees here. Yeah, not happening. There we go. Yay. All right. So everybody can hear me? And we're ready to do winter or fall 2019 test 2. And it's going to be part 4. Question 2. Here's a different approach. You want a nice way to get 6 points off the bat without even thinking about mechanisms? That's not a bad deal. I'm going to copy each of these molecules without the Br right below each molecule. And I'm going to put a cation on the carbon where the Br is supposed to be. 6 points. You want to get 12 points? Have a Br minus lone pair attack that carbon that's the cation to get these products. 12 points. Wow. So I've never given this nice little giveaway before. So I'm copying the first one. Trying my best. I'm gonna do a little better than that. And I got this. And the cation that made it has to be right there. And then I think I'm drawing the 6 first. See, and as you draw these things, you get better at drawing these things. Even a 35-year veteran gets better at drawing these things as he continues. And that's the cation that gives the second product. And then the cation that gives the third product, there's only one. Has to be that one. And there's a stray methyl here because, you know, technology. There we go. I don't like stray methyls. And the fourth product, I can't draw a 6 to start with. Oh, well, there's no 6 left. 5 in the middle, 5 on the top. Cation there, because that's where the Br goes. And another 5 down here, but things are a little tight. Doesn't look great, but it's got the ring size. And then the 5th one, everything except the cation. Everything except the cation. I got my square, I got my isopropyl, I got my pentagon. Pentagon? That's pentagon. And I got my cyclohexyl. I got the methyl and a cation. And that's 5 out of 6. I've got 5 points already. Wow. This is like a stress relief approach to this problem. There you go. I got everything. And then you want, that's 6. You want 6 even faster points? You need a Br minus every time. Do not try to do this with 1 Br minus. I'll consider giving you 1 out of 6 points, but that's the most. You need 6 Br minuses, everybody. I'll just do the arrows first. These are reaction arrows, not mechanism arrows. And I need 5 more Br minuses. Where am I going to put this one? Right here? Sure. You put the lone pair anywhere on the Br minus you want. And don't forget the minus. Oh, you do that? Forget the minus? Every time you do. If you do it 6 times, you lost 3 points. Every time you have a lone, sorry, not a lone. Every time you have a formal charge error, half point off. Force policy. So here's your point. Here's the fast point. An arrow from the lone pair to the cation carbon. Arrow from the lone pair to the, you're going to get bored. Arrow from the, oh, make sure it starts at the lone pair. Don't start in outer space. Dr. Whitaker gets upset. Not upset, upset. Sad upset. Lone pair, all the way to the carbon, please. Don't stop at the cation in this example. For example, if you do this with your arrow and it stops like there, I don't like it. What's it stopping at a bond? Electrons don't go to electrons, that's a bond. Stops at the carbon. All right, we have 12 out of 18. You want to quit? Of course you don't want to quit. We got to start the mechanism. Doing it from the end here. And you guys all know that the first part of the mechanism, no matter what mechanism you're doing Monday, is pi attacks strong acid as promised. There. 1 point for that. 2 more points for the 2 cations. How do you know where the cations go? Well, if you put the H here, the cation's the other carbon. If you put the H here, the cation's the bottom carbon. Please draw both. 2 more points. So you draw your cyclohexyl. And you draw your square. And you draw your pentagon. And it has a methyl on the bridgehead. And I don't want to keep copying that over and over. You guys, sadly, you do have to. And the 2 positions for the cation are, 2 positions are top carbon, bottom carbon. This will give product 1 and product 2. I already drew this cation and this cation. So, you know, I wasted a little time here. But not really. I can now use these drawings to rearrange. And there's 4 more products, right? 4 more products. I need 4 cations. So I have 2 copies of the top cation here and here. I'll just call those A and A. You don't have to label them A and A. Here, A, another copy of A, and this one B, and another copy of B. And let's see if you can remember from my last video. The rearrangements from this cation are as follows. There's 3 options. Let's see which ones give us what we want. You can rearrange the H off of here. I'm going to draw it temporarily. But I'm going to point out that if you rearrange this H, you get a cation on the top square, and none of the rings change, and I don't see any product where I have a Br there instead of an H. So he wasn't looking for that hydrogen rearrangement. I could have had more products, is what I'm trying to say. That H moving wasn't for one of them.
Professor, you do have a product that looks like that. It's the 4th one.
Oh, 1, 2, 3, 4. No, that ring got bigger. Moving an H doesn't make a ring bigger. So I believe the cation you're looking for there will be this rearrangement here. No, that'll give that one. Let's try the other 2 rearrangements and see what we get. Okay. The 2 rearrangements that make the ring bigger at the top, which would be these 2 products, are this bond or this bond. Moving there, I'll do them both. We'll do the one in red, where that bond moves. We'll do the blue, where this bond moves, baby blue. And I'll keep labeling cations on the screen because I don't want to draw them again. I'm going to call this one cation C and this one D. This one was already labeled as A. This one was already labeled as B, E, and F. So which letter do I get after I move this one? Well, it's going to have this bond broken. And we're still going to have this at the top of a hexagon. I'm thinking, you know, the hexagon didn't change. That's good for this guy right here. I think it goes to C. You having trouble seeing it? That's okay. Because doing that little trick at the beginning gave us the answer. So in this one, I'll just tell you, just for your education, I call this carbon number X, carbon labeled X, and this one labeled Y. So the X has the isopropyl on it. The Y will have a new bond. And next to Y at the top of the cyclohexyl will be missing left of X. Wow, I don't even know if I'm seeing this. This is tricky.
Why are you moving that bond?
Yeah, I think it's the bottom one. It's not the
It's
top
the
one.
wrong button. No wonder I'm having trouble seeing it.
Yeah, isn't it the
The
bottom one?
bottom one, and it's much more obvious than, yeah, you
Yeah.
see my little trick. I thought I was onto something. I got a little cocky. Don't do
You
that.
just wanted us to guess it right. You know what you were doing.
No, I didn't. Yes.
I
But
know. I was
thanks
trying
for
to
your
hook you up.
kindness.
I was trying to bail you out, but you didn't take it.
Hey, I own up when I make a mistake. You're not allowed to rearrange from any position except for the adjacent carbon. And what I had there before, that's not this is the adjacent carbon. You're only allowed to break this bond or this bond. That's all I ever taught. I'm not going to change. This is far away. So you saw it. I don't know what to do here. Yeah. You know, life is humbling. That's all I can say. And I think we can see it better than, not if you draw a bad arrow. All the way to the carbon, right? Good. Broke this bond. So that bond's broken. And I think it's going to give this guy. Don't you? 4 becomes 5. The next carbon over here, I'll call this Z. I don't even like my X from before.
Professor, it gives, you said D?
It's going to go to D.
Yeah, I think it's gonna give D, right?
That's what I was talking about.
Wouldn't it give C though?
No, here's
It
X.
should have 2 5-carbon rings.
Yeah, well, yeah, the 6 is getting, that's supposed to be a Y and an X. I don't like either one. X and Y. And in between's the cation. X. This breaks, makes ring size 5 there. This got cut down to ring size 5. And the adjacent carbon between X and Y is the cation. Whoa, don't erase anything. Adjacent atom between X and Y is the carbocation. So the green arrow, no problemo. Oh, look at, that's not nice. Don't even do that. There we go. All of this discussion that we spent, and it seemed like a horrible thing had happened. 1 point. If you couldn't figure out which one of those two it made, you lost 1 point. So that's A doing that. A did this to give, I didn't even draw what happens here, did I? Yeah, your two possibilities from A are that bond and this bond. Finally, I've covered those two things. But this one, I never got a result. Let's talk about this one. Do the labels again. We got an X at the top. We got a Y for where the cation is. This one's going to make ring size 5. The 6 didn't change. We're going to C here, aren't we? The 6 didn't change, leaving a cation between X and Y. And X is the one with the isopropyl. X is the carbon with the isopropyl. It's not looking good. X. And the Y is top right of the cyclohexyl. And this X is now bonded to Y. X is now bonded to Y. The top of the cyclohexyl lost a 4th bond, so it's a cation. This goes to C. And then downstairs, we're keeping the 4s. One of them involves the methyl moving, that's this one. That methyl's on the cyclohexyl. The methyl, cyclohexyl 1 away from the cyclopentyl. So this one moves here. I want to get my point. Well, a little far here. Yeah, there. And that goes to F. And this guy is the other one. Shrinking down. Got to go to E. Well, in E, the cyclopentyl becomes a cyclohexyl. So this guy, instead of the methyl moving, that guy moves, and that gives E. And now I don't like this at all. Teachers want to be clear if they can. There you go.
Professor, on our exam, is it going to be 6 problems or 4?
You need to read the study guide.
Yeah, it said 4, right?
Correct.
Okay, I'm just double checking because you just made it. What if you change your mind?
I'm not going. I can't change my mind from the study guide.
Okay, okay.
I will have justified complaints, and I do not like those. I like trying to be fair.
All right, perfect.
Okay.
At the molecule at the very bottom, did we also move one of the carbons from the ring, the lowest ring? Yeah, this carbon.
That could have been another. That could have been another product, an 8th product, because we already talked about moving the H from the cyclobutyl. Could have done that, and we could have moved this bond as well, but neither of those products is listed, and we're thinking less products, not more now. Yeah, I won't. There will not be all possible products on this question. 4 out of all possible products is what you will have. So that good? I think we had a good review session, but we had a request for one more problem.
What about the 2 major products formed?
Oh, we never even did that or the explanation. Thank you.
But Professor, just a quick one. You said since there's 6 here, that means you said all of them don't form, so you would draw like 3, half of them. So since there's 4, we would be looking for 2 that rearrange, correct?
Probably.
2 or 1, right?
Reasonable assumption, yes. I can't guarantee it, but
Okay.
what you said is a reasonable assumption. You want to circle the 2 products where the cyclobutane is gone and talk to me about that.
Most
We're looking-
hypoconjugation.
No, I don't want to hear about hyperconjugation, not on this one.
Okay.
You're going to need to talk about the 2 cations that gave those things, which are this one and this one. So just say C and D. C and D both have, I need the magic words for the type of strain that they have reduced.
Torsional.
Yes. Torsional. And that's because of eclipsing, but you don't have to say that. And what's the other strain?
Angular.
Yes, I'll take angle or angular. Angle strength. And that's part of your explanation for why you circled the products that came from C and D. And so that would be your answer to C. So would the circle. No, it's B. Yeah, I don't always separate them, as that's why that happened. There you go. So yours is, I think, 12 here, 12 on top, and 1 and 3. So still a lot of points, 16 instead of 22. All right, and we had a request for a,
I'm actually good with that question. I knew what the error that I had, but if anyone wants to go over it, that's fine.
yeah, it's a good practice. In making your test, I realized this is fully tested in part 2. So I don't believe you'll see multiple choices of this, but this is good practice for part 2, where you have to do all the parts, pKa's and stuff. And it's got an extra level of thinking, which, you know, takes time. So that's why I probably took these. I did take these off your multiple choice. A version of these does not show up. I know we just lost half the audience, but let's do it anyway. What do we want to do? We want to do our usual. Now,
pKa's.
which of these two pKa's is a higher number? Because that means it's a more stable molecule.
The nitrogen.
Yeah, the one with a nitrogen is going to form because it's more stable. Forget about this one. That's a pKa -3. If you have a choice of a -3 or a 10, then you're not going to pick the -3. I want to form stable stuff. That means this is the acid. This is a base. There's the base's conjugate acid. Yeah, forget about the K's. They're just watching. It even says that right there. There's a minus on each side of this baby. That's carbonate. And this is bicarbonate.
Yeah, I thought it was a carboxylic acid in the beginning because of the
that'll do. You are not the first to make that small mistake, but you're not going to do it on Monday now because you made it now. This is the acid in the, first of all, do we agree in this pair, the one on the left is the acid. It's got the extra hydrogen, and that's 11 because it's bicarbonate, one we have to learn. And we're going pKeq. Left one is 11 minus the right one is 10, -1. Boom. And then in the previous product, in the previous question, product blank will be created in, that's product X.
Professor?
Will be created a higher amount, and it is in the ammonium. Yeah, it's an ammonium. 1 second there, Mr. 1 second. Sorry, almost used your name by mistake. Although I suspect it wouldn't have been a problem.
No, it's fine. You can.
All right, Ali. All right. So product X is better because it's more stable and it's an ammonium. So X ammonium, X ammonium, X ammonium, B. And then we have a question from Ali.
Yeah. So I thought on the right side, like we always use the lower pKa, the one that's lower. Why'd you use the higher one?
Okay, now this is where words are fun and good, but your words were for a totally different scenario where if I had a molecule where I had to decide which acid to use in this molecule, and would you use the 25 or would you use the 17?
The 17.
Use the 17. It's a stronger acid. Something's got to be taken off of this thing. Here I said, you should approach it this way. Which one of these has a lower pKb? The nitrogen, pKb4. This is further review of part 2. pKb equals 14. And I'm going to make your question exactly what you said. That's a 10. 4 versus a neutral oxygen, pK. Oh, it's going to switch pages on me. I'm not careful here. pKb 14 minus negative, I used the 3 or the 2? -3 is 17. Hey, now we can use your logic. Which of those is the better base? 4 or
4.
17? You better use the 4. Forget about what you were just talking about. You've never seen a problem where I give you 2 hypothetical products and pick one.
So you're not gonna do that on
It's
this
a whole
exam,
new
right?
ball game. But this covers it. If you have a choice of 2 bases, which one do you use first? Stronger. Similarly, down here, if this thing's our acid, totally unrelated to this question, which one do you pick as the pKa that you use? And it's that one because it's stronger.
So basically, on the pKa, on the exam, use the lower one still. This was just like a rare occasion.
Well, this is the same but flipped. This is not an acid in this question. It's a base.
Oh, okay.
How do I know? Because this is an acid of this. So this better be a base. And then it's the exact same thing as you were talking about. Given a
Okay.
choice of 2 bases, which one do you pick? Lower pKb. Okay?
Okay.
Shouldn't the
Same
pKa
story.
be 1?
If your molecules, if this was, you determined this had to be an acid right here. If you determined this had to be an acid because it was reacting with a base, which acid do you pick? Stronger acid. That's the thing. And we had a question.
Or shouldn't the pKq be 1 instead of -1? Because of
Yeah, if I did proper math based on, doing math in this universe, then that would be the answer. And I'm glad that came up. Trying to grab my circle and move it here. It won't let me. I just want the circle. Why are you doing this? Oh, because oh, we can do that. How's that? Except my plus sign didn't move too. There we go. Yeah, 11 minus 10 is not -1. Okay. Yeah, that's a great question. If I post that video, there'd be no end of trouble, right? Okay. That's about all I got time for today, unless you have like a last second question you want to ask.
I have a question. It's for winter 21,
Okay.
test 2. It's part 2, question 2.
Winter 21, test 2. Let me get caught up with you here. Winter 21 is what you said. Test 2. A lot of tests. It's okay. It's good. Winter 2021. That'll be right near the bottom, right? Yeah. There we go. Test 2, opening both versions. So is it the first exam or the second in the document?
I think it's the first one.
And I'm just waiting for it to show up here. I think that's it. Yeah. Okay, I'm sliding it over so we can all look at it. Part 2, you said?
Yeah, so my question is, let me see. Yeah, you got that. My question is why didn't we use carboxylic acid versus the ammonium?
Okay, it's the long
Is it
story
because
is
it's
this one's an acid,
yeah.
so this is a base.
Mhm.
This base has a conjugate acid over here, and now the question is, which of these protons on here now is the strongest acid? Correct?
Yes.
And if I used an ammonium, then your concern is valid because the carboxylic acid is the strongest acid available,
Mhm.
4.9.
Yes.
And that wasn't my answer.
Mm-mm.
Wow. Okay, we're gonna come back with a video to solve this problem and make it very clear there was a mistake on the answer key. Okay, so we
Oh,
gotta,
okay. Professor,
So
can I
that-
ask you a quick question though?
yes,
Just a quick. Can you scroll up just for a second? It's a quick one. I'm not gonna make you do it. I promise. On this kind of question, I would pick the lowest pKa. Correct?
in this, let's see, this is a base because it's got one less proton than this. So this is the acid, this is a base.
Yeah.
So that makes this an acid. You gotta pick the lowest pKa that's available here. You got a 45, you got a bunch of 50s, and you got nothing because ether doesn't have a proton on
Yeah.
the O. So you're gonna use the 45 off the alkene.
Okay, yeah. So on these kind of problems, you use the lowest pKa. I was just making sure.
On
Okay.
all kinds of problems, use the lowest pKa.
Okay. Okay.
There's
Perfect.
always more than one pKa to choose from.
And you always use the
Seriously.
lowest.
You always
Yep.
use the lowest.
Okay.
I'm
perfect.
gonna set up for winter. I'm gonna keep forgetting this is winter 2021. This is gonna be on the screen when I come back, okay? All right, bye-bye.